Everyone, it's Mr. Rops here, and we are going to talk about the quadratic formula and PEMDAS backwards. And this is backwards, PEMDAS backwards. So, and then whenever we're going to do PEMDAS backwards, we're going to have what's called vertex form. So when the quadratic appears and is written in this pattern, where I have a pattern of x plus or minus some value h, and it could be a number, squared, plus some value k equal to 0, and there could even be a number a in front. We're going to solve by doing PEMDAS backwards. Okay, so an example what it might look like, it might look like 2x plus 7 squared minus, let me think about this, 50 equal to 0. Some kind of scenario like this, where I have a squared. That's the key, where you have these parentheses squared, there's number on the outside, and I can do PEMDAS backwards. Just recognize that, and we'll talk about how you would do it. So let's look at an example here. If I was going to solve this, the easiest way I would do to solve this is I would go graph it. I would take that, I would throw it into my calculator, or if I'm even luckier, Desmos, and there, look at this. I can see that I have two x-intercepts, and so I would solve it, be negative 13 and 5. And so if I draw a quick sketch, I get this is negative 13, and this is 5, and this is the equation y is equal to x plus 4 squared minus 81. And so x equals minus 13, and x equals 5. There we go, all quickly taken care of. Now, doing algebra, what I could do here is I'm going to do the PEMDAS backwards. PEMDAS backwards. And I always mess this up. It could be either way because the order of the D and the M doesn't matter. And I'm going to do it backwards, which means I'm going to try and undo all the algebra to get to x, because there's a single x. So what I do then is I'm going to take this equation, and I'm going to add 81. X plus 4 squared is equal to 81. And then I'm going to get rid of the square by taking the square root of both sides. And when I take the square root of both sides, I have to remember I've taken the square root, so it could be plus or minus 9. And so now I have two answers being introduced here. And so then it could be x, I subtract 4 from both sides. And then it's x is equal to minus 4, because I've subtracted 4 from both sides, plus or minus 9. Well, that has two different answers. That's minus 4 minus 9, which is negative 13, equal to x. Or it has x is equal to minus 4 plus 9, which is equal to 5. And so by this method, which may seem a little confusing at first, you get these two values, but this is by far the most efficient way if I don't have my calculator. Okay, that's one way to do it. That's PEMDAS backwards, and it will work when it's in this form where I have some quantity squared plus or minus a number equal to 0. But this is the key. I have one single x, and I can undo algebra to get x. The other method I could do, the second algebra method, is I think the harder way to do it. I'm going to take x plus 4 squared, which means x plus 4 times x plus 4 minus 81 is equal to 0. And I'm going to expand this out. I get x squared plus 4x plus 4x plus 16 minus 81. Expand x times all those, 4 times all those, collect like terms, and I get 8x minus, I'm going to get 65 equal to 0. And then I ask myself the magic question, what two numbers multiply to get 65 and add to get 8? Well, because I've already done it twice, I know one of them is going to be negative 13, and the other is going to be plus 5 equals 0. Oh, I got that backwards. Hold on. This is going to be positive 13. Positive 13 and minus 5 will get me the positive 8. So that means x plus 13 equals 0, or x minus 5 is 0 by the null factorial, because I multiplied two numbers to get 0. So x is equal to negative 13, or x is equal to 5. So either way you do it, you're going to get the same answer, but this is more straightforward. And the analogy I like to use is a game of chutes and ladders. If you remember this game as a kid, the idea was to go spaces all the way up to get to the top here. But every time you came to a ladder, you could bypass and go up to the top. You go some more numbers, and if you land on 22, you go up and all the way over. And so you could get up to the fast quicker by doing shortcuts. And then the chutes, though, would take you all the way down if you missed one. What I think the PEMDAS backwards is like taking a ladder. It's a shortcut to getting to the end. And you could take all the path, but PEMDAS backwards I think is the shortest way of doing it, as opposed to expanding it all out, collecting like terms, then factoring. Let's try another example here. Let's take this and put it into the graph. And notice I have something on this side of the equation. So I'm going to graph it where this side here is one equation and this side here is a second equation. And so if I go over to Desmos, I have this first equation is going up like this in red, and then the second equation is negative 2. And so here is y equal negative 2. Here is the other equation, y is equal to negative 2x minus 3 squared plus 30. And I'm looking for these points of intersection. Using Desmos, I can see quite clearly negative 1 and 7. So this is negative 1 and this is 7, and so x is equal to negative 1 and x is equal to 7 is our solution. If I'm going to do PEMDAS backwards on this scenario here, the first thing I'm going to do is I am going to subtract 30 over. So I get negative 32. And then I'm going to divide by negative 2. If I divide negative 32 by negative 2, I get 16. And now I take the square root to get rid of the squared. And when I take a square root, it's always plus or minus when I'm the square root taker. And that ends up being plus or minus 4. And so I add my 3 is equal to 3 plus or minus 4, which gives me two answers. X could be 3 plus 4, which is 7, or x could be 3 minus 4, which is negative 1. And so that gives me two different answers. And so this idea of PEMDAS backwards is a nice, efficient way of getting to the equation.